Hello people! Welcome to this tutorial on making animated charts. We are going to do this using Python, Matplotlib, and Seaborn. This visualization will represent the ratio of population of the two most populous nations with respect to the world. Let's first look at the recipe for cooking this visualization. First, we would need an IDE. Any IDE of your preference would do, but if you're a beginner, I would suggest Google Colab. Secondly, we would need the data. We are going to use the World Population Dataset from Kaggle, which contains data from 1950 to 2023. Next, pandas. This library is vital to load and transform the data. Most importantly, we would need the visualization libraries, Matplotlib and Seaborn. We can ideally achieve this using Matplotlib alone, but Seaborn gives us options to improve the aesthetics of the plot. Now that we know what we need, let us look at our approach. First, we load and transform the data using pandas. Next, we calculate the ratio of the population of India and China with respect to the global population. We then create a Seaborn chart for each year, and then animate it using Matplotlib. The code is split into three parts: setup, code, and driver. The setup part contains the library imports and configurations. In this case, we import pandas, Matplotlib, and Seaborn. We also import the animation module from Matplotlib. We configure the Seaborn theme and set global parameters for Matplotlib plots. Setting global parameters helps in eliminating the redundancy. Else, we would have to set them every time we need a value other than the default. The code part contains the modularized code. The entire code is contained in a class called Animated Charts. It has three methods and a constructor. The code in the class does not execute unless it is instantiated. In the driver part, we instantiate the class and pass parameters to it. The parameters are taken up by the init constructor during the instantiation. Then, we call the run method, which triggers the other methods according to the requirements. Let us dive deeper into the individual parts of the code. The init method takes in a dictionary of parameters and creates attributes of the class. In this case, we pass only the number of frames or interpolations between two consecutive years. We define the other attributes like a list of years and data. Any variable that is used across multiple methods should be made an attribute of the class. And any attribute of the class should be defined in the constructor method. As the first step, we load and transform the data. We transpose the data from a country indexed format to a year indexed format. This will help us easily perform the calculations necessary. Here is a simplified demo of the transformations in this method. This is how the initial data looks like. We have the population data of all countries from 1950 to 2023. The data is country indexed. We transpose the data frame into a year indexed format. The countries become the columns, and the year becomes the index. Note that all the countries, except India and China, have been abstracted as others. We create a new column called World, which is the sum of populations of all the countries. Next, we calculate the ratio of populations of India and China. The ratio of populations is all we need, so we drop the world column. The transformations are done, so we move on to plot the data. First, we decide the size of the plot. For a video of 1920 by 1080 resolution, we would need a 19.2 by 10.8 plot, with a DPI of 100. We set the title of the plot, and decide on the colors for the bars for India and China. For India, we choose a greenish color, and for China, we choose a reddish color. Note that we have two subplots, one each for China and India. The next task is to set up an animation routine. This requires a matplotlib figure, which we just created. We need a helper function called animate, which we will come back to in a minute. We then require the number of frames. Number of frames is a vital parameter, because it decides the number of times of execution of the animate function. The number of frames is calculated as the product of video duration in seconds and the frame rate. If we plan to show 1 year per second, we need 74 seconds. We would not want to abruptly end the video once the visualization is complete. So, we allow a fade-out duration of 5 seconds, which brings the video duration to 79 seconds. To ensure that the frame transition is smooth, we pick a frame rate of 12. To make the video smoother, we choose to fade each bar into the frame, instead of making it appear abruptly. This is why we need a frame rate of 12. We have now set up the animation routine. The most important part of the animation is the helper function, called animate. We earlier decided to show 1 year per second. So, we would need 12 frames for a year. So, at every 12th frame, we switch to the next year. For every frame, we take a copy of the original data. We set the values to 0 for all years greater than the current year, so that it comes up as an animation. We also pick the colors for the bars. If the year is less than the current year, we set it to the base color we chose initially. For the current year, we need to make the bar fade in. We achieve this fade in effect using an alpha factor or opaqueness factor. For each frame ranging from 1 to 12, we gradually increase the opaqueness of the bar by multiplying the color with a factor that has values ranging from 0 to 1. Next, on each subplot, we make sure to clean up the axes to eliminate any residuals from the previous plots. We then plot the bars using the custom-made color palette. We set the y-axis limits and make some cosmetic changes, like rotating the x-axis labels, displaying grids, etc. We finally return the axis object. To have different colors for each bar, we need to specify the hue parameter. We also pass the appropriate axis for the ax parameter, so that the bars go into the correct subplot. This returned axis object is picked up after every iteration and compiled by the Funcanimation routine into a video. This can be saved to disk as a video file. Here is how the visualization would look like. For the demo, I have chosen a smaller frame rate. Feel free to experiment with a higher frame rate to ensure a smooth transition. Today, we learned how to create a chart visualization video using Python, Matplotlib, and Seaborn. Hope you enjoyed it. I'll meet you again with another interesting video. If you like what you see, experiment with it. Don't forget to subscribe. Until next time, happy learning!